hello everyone, we will continue with the overview of the course. Okay. So, in last class we have discussed about the topics on sampling methods. So, there in sampling methods and sample size we have discussed that we will cover the meaning of sampling, then aim of sampling, then factors govern sampling method, type of sampling, terms commonly used in sampling, sampling stages of textile material, concept of critical difference, fiber sampling from bulk, fiber sampling from tuft, sliver or roving or yarn, because this sampling of fiber is from bulk or from tuft. This is say tuft, bulk is in the form of say bale. Okay. It is entirely different. Tuft is softer one. Okay. From here we can take the sample, okay. But for from the bale we have to take different precaution, okay. That those we will discuss, and from sliver the sampling if we try to take, it is entirely it is extremely tricky. Now, I will give one example, although we will discuss later also. Suppose this is the tuft, okay, where the fibers are randomly arranged, okay, randomly arranged. So, we can pick up small quantity of tuft, okay. There it represent entire quality, entire, because here we have short fibers, we have long fibers, everything is there, okay. But in sliver if we see, these slivers are arranged in a particular order, say parallel. Here if we try to pick this fiber from the side, suppose I am trying to pick sliver fiber from the surface, there the problem would be that the longer fiber will have more higher probability to be selected. That means, it will create a length biased sampling. On the other hand, if we try to pull the sample from the edge, from the end, then it will not create the length bias sample, and detailed we will discuss, and then yarn sampling, how to sample yarn, then fabric sampling, determination of sample size, test of significance and control chart, and practical statistics. So, this will be discussed, all this will be discussed in the sampling method and sample size, that segment, initial segment. Okay. Next we will start the actual testing of textile material. We will start with the evaluation of fiber length. Okay. Different types of expressions of fiber length related characteristics, like fiber lengths are expressed at by different terms. It is not the fiber length, we sometimes call it as mean length, we can call it as span length. Span length is also divided into various terms, 2.5% span length, 50% span length, okay. And this staple length, upper half mean length, so upper quartile length. So, various terms, okay. This definition, these terms we will discuss in detail, okay. And we will try to understand the importance of these terms and how to use these terms in practical, in actual application. Okay. Meaning and relative importance of these terms. what are the meanings and what are the importance of these terms. Okay. Then methods of measurement, various methods of measurements are there, okay, to test the fiber length, okay, and their dispersion. These methods are, first we will start with the hand stapling method, then Shirley photoelectric stapler. So, this hand stapling method, it is by hand, we quickly we come to know the length characteristics of the bulk of the material, and its mechanized version is same characteristics we measured here, it is a staple length by Shirley photoelectric stapler, it is a mechanized version, we will discuss in detail. Then comb sorter method, where we test the effective length. Okay. Then single fiber length measurement. So, we will discuss the how to measure the single fiber length. Then length measurement by weighing method, we can take the mass and then based on the mass and the class size, we can calculate the length of the fiber. Another weighing method is, it is called clamped taft method. Clamped taft method, it is used mainly for sliver and all this type of fiber, those are almost parallel in nature. So, here we use for, if we want to test the length of the fiber from the sliver, we use clamped taft method. So, various methods they are used for different types of fibers. Then photoelectric method, it is a very popular, it is a widely used method, it is called fibrograph method. So, where we get the span length or upper half mean length, okay. This we will discuss in detail, their principle, and related numericals also we will discuss. Okay. And in photoelectric method, main technique is that tricks is that the sampling method, how to produce the sample fiber sample, and there to the students there are confusion how to test the, how to select the sample. This detailed I will discuss here, okay, photoelectric method and related numericals, the things will be very clear, okay, after that. Then Weyra fiber diagram, it is basically for wool fiber, okay. So, it is it works in the capacitance principle, then wool fiber length by almeter, okay. So, these are the methods, okay, and in HVI also they use, but it is a almost fibrogram method, okay. HVI they use the fibrogram method. Next is the evaluation of fiber fineness. So, fiber fineness, normally in any other engineering material, if we want to know the fineness, we simply calculate the measure the diameter, any material. So, fineness of rod, fineness of wire. So, it is a simply measure the diameter, but textile material it is a complex material, here we cannot measure directly the diameter because of various reasons, that those we will discuss detail, because the fiber they are not circular in nature, they are not uniform. So, that we have to measure the fiber fineness indirectly, and most popular expression is that fiber mass per unit length, that is the indication of fiber fineness. So, what are the importance of fiber fineness, that we will discuss, why do we want to measure the fiber fineness. So, this we will discuss here. Before we measure we discuss the methods, okay. We must know the importance of fiber fineness, then different methods of measurement. There are various methods, we will discuss each and every methods. First is the gravimetric method, it is for cotton. Next is that gravimetric method for wool. So, there are two different gravimetric methods that we will discuss. Then microscopic method of measurement. So, microscopic method of measurement is basically for the fibers those who are actually circular in nature. So, that is basically for wool we use microscopic method, because wool more or less it is circular in nature. So, that is why wool, if we see cotton is expressed in terms of mass per unit length, but wool generally is expressed in terms of micrometer, because wool is little bit circular in nature. Wool is not expressed in gram per or mass per unit length, wool is expressed in terms of micron. Okay. Then method is that air flow method, which is indirect method of knowing the fiber mass per unit length. Then optical fiber diameter analysis, this we will discuss OFDA, and next is that light scattering method, fiber diameter analysis, FDA method, detailed we will discuss here. Okay. And another important method, it is a vibration method, using the principle of vibration of string we can measure the vibration fiber mass per unit length. Okay. So, after evaluation of fiber fineness, next we will start the maturity. Maturity basically it is a matter of the cotton, it is a maturity is limited to cotton, other fibers we do not measure the maturity. Okay. And maturity affects the immature fiber, affects the quality of material adversely. Okay. Those detail we will discuss. So, concept of maturity of cotton fiber. So, here we have mentioned the maturity of cotton, because we are not going to discuss maturity of other fibers, and for definitely for man-made fibers we do not need maturity. So, concept of maturity of cotton fiber, and there are various parameters to express the degree of maturity, that those we will discuss to understand these parameters. So, these parameters are degree of thickening, maturity ratio, maturity count. So, these are the expression of maturity. Then we will discuss the various methods of measurement of maturity. These methods are caustic soda and microscopic method, it is a very common method, it is used for cotton fiber. That is obviously cotton is we are only concerned about the cotton, caustic soda and microscope. Then caustic air method, it is indirect method of measuring the maturity, which also takes care of, which uses by using caustic soda also here, but method is different, that we will discuss here. High volume instrument method of measurement of maturity, although here they use the airflow method. AFIS method of measurement of maturity. So, then double compression method of measurement of maturity, this we will discuss. Near infrared method of measurement of maturity, image processing method of maturity. So, these are the methods we will discuss. Next we will discuss the basically two methods which are very popular for very quick use, quick data. Okay. One is called high volume instrument, HVI, and there in that instrument we test a number of characteristics together, it is not the single. Okay. Length, fineness, strength, everything we can test. Even here we can test the color, trace percentage, that we test. So, this principle of HVI we will test, and there how to analyze the data, this we will try to understand here. Similarly, an application of HVI. Then another set of method, that is called advanced fiber information system, AFIS system, where again we will see the AFIS data analysis and that application of AFIS. After that, in the sixth segment we will discuss the moisture in textiles. Okay. So, first we will discuss the atmospheric condition and relative humidity. What is relative humidity, how to measure the relative humidity, this we will discuss here. And there are two very commonly used terms in textile, it is a moisture regain and moisture content. These terms we will discuss in detail, their relationship we will discuss. Then hysteresis effect of moisture, then how to measure the moisture, quantity of moisture in textile, and what are the effects of moisture on fiber properties, that we will discuss, and what are the factors which affect the moisture regain of textile material. And one important application of moisture is that to calculate the correct invoice weight, which is very important, because we actually produce the material and customer is paying for the material, not for the moisture. But it is also not feasible to give the exact dry weight, because textile materials are hygroscopic in nature. The moisture has to be there, moisture will be there, we cannot avoid. So, internationally it is accepted that the moisture has to be there, the standard allowable moisture is there, and considering that allowable moisture, so we can calculate the correct invoice weight. So, the process of calculating, how to calculate and what are the uses, we will discuss here. Okay. Next is that linear density of yarn. So, linear density means the mass per unit length or length per unit mass, because there are two processes, one is a direct process of measurement, direct system, which is expressed in terms of mass per unit length, and indirect system is that length per unit mass. So, that this detailed we will discuss, and their interrelationships we will discuss. And one important thing is that a particular material, for a particular yarn we use a particular system. There are systems like for filament we use a particular system of measurement, like a denier is the system we express for polyester or any filament, man-made filament. But for cotton we use English count, like for worsted we use metric count, like that. So, that this we will discuss, and their interrelationship we will discuss, conversion of linear densities of different systems. Okay. Then the linear density of folded and plied yarn. Suppose we know the linear density of a single yarn, what will be the linear density of say plied yarn of different linear density. So, this we will discuss here, and then methods of measurement. There are various methods of measurement of linear density of yarn. Then yarn twist, which is very important for staple yarn. So, first we will discuss the effect of yarn twist in staple yarn. So, first effect is the strength. Strength changes with the twist of the yarn. Then application of yarn twist. So, yarn twist we can use at a different way, different applications are there. Like if we want to produce a shadow effect, we can go for different mix up of Z twist or S twist, okay. Different types of twist mixing we can do. And what are the different twist levels? Twist is expressed in terms of twist per unit length, say twist per inch, twist per centimeter, and what is a TM, twist multiplier. So, which is actually indirectly which is correlating is the twist angle. So, this we will discuss here, and measurement of twist. So, there are various methods of measurement of twist, this we will discuss here. So, for single yarn there are methods, and for plied yarn there. So, these methods we will discuss here. Then yarn and fabric hairiness. So, hairiness of yarn is most of the cases it is undesirable. So, we must know the level of hairiness, so that we can take precaution. Okay. So, what is hairiness we will try to see, various causes of hairiness and problems, what are the problems which created by hairiness, and then we will discuss the measurement techniques of hairiness. So, for yarn also and also for fabric hairiness, fabric surface hairiness we will discuss. Next is that which is extremely important for appearance of a material, which is evenness or irregularity of yarn. Okay. So, types of irregularity, there are different types of irregularities are there, that we will discuss. Expression for irregularity like u percent is that which is percent mean deviation. Irregularity we can express in types of coefficient of variation also, this we will discuss here. Limit irregularity and index of irregularity, which is extremely important to know, that the index of irregularity means it to compare the irregularity of two materials of different characteristics. Okay. This we can compare, and it indicates the performance of a particular machine, particular system. Then addition and reduction of irregularity. So, how to increase the how irregularity is added or how irregularity is reduced, this we will discuss. Typically, if we stretch any material, if we stretch any strand, we add irregularity, but if we double, if we actually multiple, if we actually use more than one strand, then we are reducing the irregularity, and we will see there are some equations how to calculate the addition and reduction of irregularity, we will discuss. Then variance length curves we will discuss, causes and effects of irregularities, classification of variations like random irregularity and periodic irregularity. We will see the random irregularity is not that serious. The most critical irregularity is the periodic irregularity. Random irregularity gives the poorer performance, but periodic irregularity which is not acceptable at all. So, this we have to will discuss how to identify the periodic irregularity, the location of periodic irregularity due to fault in machinery part, this we will discuss here. Then measurement of evenness and data analysis. So, that evenness measurement, how to measure the evenness, this we will discuss here, and different data analysis of evenness. Okay. And related to evenness and irregularity, another is that it is a yarn fault. So, it is a irregularity, it is a different types of fault like long thick fault, long thin fault, slabs. These faults we how to classify these faults, this we will discuss in this segment. Okay. Next is the tensile testing of material, okay, textile material. Okay. So, tensile testing, there are various factors which affect the strength of fiber. Then tensile testing terminologies, there are various terminologies like initial modulus, tenacity, breaking elongation. So, all these terms we will discuss here, yield point. So, this we will discuss, and we will try to clarify the doubts, various confusions are there among the students. So, what is the how to convert the load elongation curve to stress strain curve. So, these things we will discuss here. Then factors affecting the test result, tensile test result. Okay. So, physical factors we will discuss here, like factors affecting, if it is as we have discussed earlier, that the length of the material, gauge length of the material, it affects speed of test. So, this affect the test result, okay, for a particular material, and related calculation we will do. Okay. And then tensile testing instruments are divided into three categories based on the principle of testing. One is called CRE, constant rate of elongation, another is CRL, constant rate of loading, and third one is constant rate of traverse. Now, the confusion comes between constant rate of elongation and constant rate of traverse. I am trying to test the tensile testing. So, my left hand is the it is a fixed jaw, okay, and here it is a right hand, this is a moving jaw. Let me draw here, this is the fixed jaw, okay. Here this one is the moving jaw, and if this moving jaw moves at a constant rate, that means elongation will be at constant rate. So, this is will be a constant rate of elongation. Now, next is that this fixed jaw, this is a moving jaw. Okay. This jaw is moving in such a fashion that loading on the yarn is at the same rate. Loading on the yarn increases at the same rate. Okay. Suppose 1 kg per minute, okay. One say 1 whatever 1 centinewton, 1 newton per minute. At that rate the testing is taking place, the loading is increasing. So, it is a fixed. So, then we will call it as CRL, constant rate of loading. So, the instruments are there which will ensure the increase in load at constant rate. Okay. But what about the constant rate of traverse? Here the thing is that this one is movable jaw, okay. This one is movable jaw, but the other jaw it is not fixed. Here this jaw also moves to measure, to actually excite, to send signal to the load measuring system. This jaw is moving at a constant rate. This the bottom jaw is moving at constant rate, top jaw is not fixed, top jaw also moves, but not at this rate, at the rate of bottom jaw. That means, it is neither the CRE nor the CRL. So, that is why this method is termed as CRT, due to the fact that this bottom jaw is traversing at constant rate, okay. And this detailed method we will discuss in during the course. Okay. And next is that tensile testing methods, different testing methods we will discuss. It is we will start with the fiber bundle testing, then single fiber testing, then yarn tensile testing and fabric tensile testing. They have their various standard methods are there, we will discuss in detail. Next comes the serviceability testing. Okay. It takes care of the tearing testing, bursting testing, okay, rubbing testing. Okay. So, these are related to serviceability. It is during use we actually the fabric counteract all this type of issues. These are not regular testing, okay. Like tear testing, tearing only occurs occasionally, okay, when there is some sharp object comes into and also some hooks are there. Okay. So, that is why these are serviceability testing. We will start with the various factors which affect the tear testing. Then tear testing of fabric, obviously fabrics we are talking about here. There are different types of testing. It is a single rib tear testing which is known as tongue tear testing. So, we will discuss this testing. Then double rib tear testing, wing rib tear testing and element of tear testing. Okay. Various tear testings we will discuss, and first 3 testing, single rib, double rib, wing rib testing, it requires the tensile testing instrument, and that is why this instrument, this 3 methods, they follow CRE principle. If it is asked among this which are the methods which follow the CRE principle, these 3 methods they follow the CRE principle, constant rate of elongation principle. But Elmendorf testing, it follows the it's a sudden impact, okay, sudden impact pendulum principle, it's okay. It measures the tearing energy, this we will discuss here. Then comes another serviceability testing, which is a bursting. Bursting is also not normally, it is not common testing, it is for specific application we test, and there are various technical textile where bursting is extremely important, like parachute fabric or filter fabric, where we need to test bursting. Normally we do not test bursting for apparel fabric, but for technical fabric it is required bursting test. Like for geotextile, bursting testing is important, where the direction of force is not unidirection, it is a multidirectional force application. So, we have to understand basic understanding of bursting strength and their importance we will discuss first, then bursting strength of fabric measurement, we will discuss the diaphragm type of bursting strength, ball bursting strength. Okay. Then abrasion and peeling. So, during application, during service, the fabric gets abraded. It is not required for during production, but during application it gets abraded. So, abrasion testing is required. So, basic understanding of peeling will, and what is peeling will, how peeling forms, this we will discuss here, and grading and measurement of peeling. So, how to grade the peeling, that we will discuss, and ICI peeling box is there, random tumbling peeling testing is there, then peeling test by Martindale abrasion tester, this we will discuss, and basic understanding of abrasion. So, peeling and abrasion, they are interrelated, but abrasion is something else basically which abrades the fabric. It may or may not generate the peeling, but it actually deteriorate the quality of fabric, where we will discuss factor affecting the abrasion resistance. So, for a instrument, if we measure, there are factors, if we change the factor, you will get a different abrasion result. Okay. And measurement abrasion resistance, that we will discuss. Martindale abrasion tester is there, accelerator abrasion tester is there. So, this we will discuss. Next comes to the low stress mechanical characteristics of fabric, which is related with the fabric handle, where we apply low stress, it is not high stress, we are not going to go up to the breaking point. Okay. So, low stress mechanical characteristics, it talks about the bending. So, bending of fabric will measure, will understand, and then shear characteristics of fabric, these are our low stress characteristics. Then drape characteristics we will measure, drape coefficient we will try to measure, see, and then we will discuss the detail in detail the KESF method, Kawabata evaluation system of fabric, KESF, which deals with the all the low stress mechanical characteristics. Another low stress mechanical characteristics instrument is the FAST, FAST. Like bending, we will discuss different types of bending, cantilever bending, the loop type bending. So, all this bending we will discuss here. Okay. And next is that the transmission characteristics of textile material. Transmission characteristics starts with the air permeability. So, basically any fluid transmission through material we will discuss. Measurement of air permeability we will discuss. Then liquid transmission, so wetting and wicking. So, absorption of liquid and transmission of liquid, wicking characteristics we will discuss here. Transplanar wicking or transverse wicking, that is it is a cross plane across the thickness of the fabric, how the at what rate the liquid transmits, that we will discuss here. Then in plane, along the plane the liquid transmission characteristics we will discuss. Then vertical or longitudinal wicking characteristics, then water transmission through geotextile, that is the transmission characteristics of water through geotextile. There are methods of measurement we will discuss here. Then moisture vapor transmission through material. So, there are various methods of measurement of moisture vapor, I am not going in detail. So, that we will discuss the moisture vapor transmission. There are cup methods are there, like sweating guarded hot plate method is there, all these methods we will discuss. Then heat transmission. So, heat transmission is guarded hot plate method is there, then TOG meter is there. So, heat transmission, measurement of heat transmission through textile material we will discuss. So, this is overall the total outline of the course, overview of the course. So, from next class we will start the actual course, actual test methods, and we will start with the statistical or sampling method. Okay. There is a normal condition method, it is the normal heat transmission at normal room temperature, and extreme condition in flame condition, how the heat is getting transmitted. Okay. And that is all. Thank you.